Greetings. I want to talk about humanistic education for the future, statistical literacy. Now, I know the word statistics is going to put off a number of colleagues, but stay with me. I want to talk about the problems the humanities had between 1970 and 2000 and how they lost ground. Then I want to turn to the new directions in the humanities conferences starting in 2002. And then look at what's happened in the 20 years since this conference began, saying it's lost more ground. Specifically, it's lost ground to the social sciences. And then I want to turn to the good news. Progress. Statistical literacy as a discipline designed for faculty and students in the humanities. No computers, no algebra, no exponents, arithmetic, and critical thinking. Between 1970 and 2000, UCLA showed these results for the college freshman survey. Developing a meaningful philosophy of life for college freshmen dropped from almost 90% to 40%, whereas being well off financially increased from 40% to 70%. These are headwinds for the humanities. These are tailwinds for majors like business, computers, computer science. Yes. Within the humanities, let's look at two terms. There's Google Ngrams, and we have the word classics remaining relatively constant, whereas the term postmodern increased tremendously between 1980 and 2000. And we all know postmodern wasn't invented in 1980, but we're talking about how common it is. So what's going on inside the humanities has certainly changed over that time. And then there was the Sokal hoax. In 1995, Sokal submitted his paper, Transgressing the Boundaries toward a Transformative Hermeneutics of Quantum Gravity. His paper was a farce. His submission was a hoax. One person, Gantarsky, noted that this publication and its subsequent furor offered the most serious challenge to research in the humanities in the past half century. He argued that the Sokal affair had these results. Humanities research would be seen as frivolous, as lacking in intellectual or academic standards. He was worried that funding would decrease. This is not good for a discipline. Did this destroy postmodernism? We know the answer to that. No. But it may have contributed to the loss of interest by students in the humanities. There were a lot of other forces that placed the humanities under attack. You have skepticism, relativism, egalitarianism, materialism. We talked about that with business, anti-intellectual romanticism. And then a different set of forces with fundamentalism, creationism, and a variant of multiculturalism, all hitting on what I think of as being general education. What's truth? What's science? What's the good? Philosophy wasn't helping. Modern analytic philosophy had said, you can't get an ought from an is. You can't get what's good about a human being from their nature. And the whole idea that assumptions are arbitrary. There's no foundation. There's no there. So Paine argued that because of the assault on humanism by such theorists as Lacan, Derrida, and Foucault, humanism would seem to be in disarray. Spock cited this disarray as a reason for forming the American Academy of Arts and Sciences. This is not good news for a discipline. And so, what was the result? The humanities lost ground. U.S. bachelor's degrees from 1970 to 2000 in English and English literature decreased from 64,000 to 51,000, a 20% decrease. It's even worse when we take it as a percentage of all college graduates, because enrollment was certainly increasing between 1970 and 2000. So it was in this context that Monash University organized this conference, New Directions in the Humanities. They wanted to address this disarray. And they said, the Humanities Conference aims to develop an agenda for the humanities, a new agenda, a new direction for the humanities, different than what was being done before. Wanted to revisit the role of the humanities and reopen the question of the human for pragmatic and redemptory reasons. That was the ambition in 2003. What happened between 2003 and now? Well, we have data from 2001 to 21. What happened to the majors in English and English literature? They dropped again from 51K to 36K, a 30% decrease. Now, if you recall, back in 1970, there were 64,000 degrees, and now we're at 36,000. We have almost a 50% decrease, cut in half. And you see departmental FTE being cut. Can you see faculty not being replaced? Can you see students that are less excited about studying English literature, the different works and creation of the human mind over the centuries? Well, where are these students going? The social sciences. The social sciences can identify, they can measure social problems, and they recommend solutions using statistics and scientific methods. How can the humanities compete? Basically, we're at a point where no one really seems to care about the humanities. The social sciences get more attention. They focus on current issues, and they use statistics as evidence. The humanities, they seem lost in the fog of antiquity. Social sciences seem more scientific, more now. They offer objectivity, whereas the humanities have really gotten themselves into a position where it's not just relativism or subjectivism, but there's no there. Students in the humanities, the faculty in the humanities don't know how to evaluate the objectivity, and I say the apparent objectivity of social statistics. They don't know how to compete. There's an opportunity here, a tremendous opportunity, because the objectivity of the social sciences is all too often a charade, a false sense of superiority. Who is operating from behind the curtain? The social sciences have their Achilles heel. They avoid dealing with two problems, both involving everyday statistics. The first problem is confounding. Confound. Things that confuse will confound a person. Things that are found with something else are confounders. Now, you may have taken a statistics course, but I doubt that you ever heard the word confound, confounding, or confounder. Hold that thought, because it's critical to opening doorway, the connection, the hallway between the humanities and the social sciences. Secondly, everyday statistics are assembled. You say, every college student took roughly 12 years of math. We never talked about how 2 was assembled, how it was defined. But we're talking about statistics. I'm saying humanities faculty and students need training to understand these problems. These problems are not addressed in a traditional statistics course. I want to talk about statistical literacy as a new discipline. Statistical literacy, it's critical thinking about everyday statistics. And you say, critical thinking about numbers? There's no critical thinking there. It's deductive. 1 and 1 is 2, 2 and 2 is 4. That's it. You don't do critical thinking with math. It's deductive. Critical thinking is inductive. Strength of evidence in supporting a disputable conclusion. No. But I'm saying we're talking statistical literacy. It's critical thinking about everyday statistics that are being used as evidence in arguments. And everyone in the humanities should perk up their ears when they hear the word argument, because that's our turf. That's where we live. So most everyday statistics are based on observational studies where confounding related factors have more influence than the randomness that students study in taking an introductory statistics course. This is a different course. It has less than a 30% overlap with a traditional statistics course. Most U.S. college graduates have taken statistics, but they never study this phrase. After taking into account, here's where the humanities live. If you take into account this, if you look at it from this perspective, if you view it through this lens, that's what's missing in traditional statistics. That's what's essential in statistical literacy. Now, I want to talk about the difference between statistics and numbers. Statistics are numbers in context. Anyone in the humanities says, context. I understand context, but I've never heard that word applied to a number. I'm not even sure what you mean. Well, let's take something simple in arithmetic. 1 and 1 is 2. You see, I learned that a long time ago. I'm saying that's not necessarily true for statistics. You say, I don't know where you're going. In bunny math, 1 and 1 can give you more than 2. In ice cube math, 1 and 1 can give you less than 2. Statistics are numbers in reality, about reality. And the reality matters. It matters a lot. Numbers get rid of the reality. They get rid of the matter and deal just with the form. Statistics are concerned with the matter. Statistics are closer to words than to numbers. You say, I've never heard this. Statistical literacy is new. It's a new discipline. Here are the 4 most important things. Or at least I'll say 4 important things. Number 1, statistics are numbers in context. That means they can be influenced by the context. And I want to show that to you here in a few minutes. They're socially constructed. I'm not saying there's no reality. I'm just saying they're constructed the same way that words are constructed by people with motives and values and goals. Yes. And what's the best advice? When you're working with words, take care. When you're dealing with statistics, take care. So let's look at some examples here. I want to talk about the diabolical denominator. We're just going to talk about simple ratios here. We're talking about COVID death rate. And which state, Michigan on the left, Rhode Island on the right, has the higher COVID death rate? Well, you say, if we're just talking about frequency, the bigger state probably has the more deaths. No, we want it per case. I'm sorry, that's wrong. We want a death rate per something. Look at the bottom of the pyramid. Per million population, 1662 for Michigan, 2521 for Rhode Island. Rhode Island has the higher COVID death rate per million population. You say, okay, that's numbers. That's numbers. But now let's do it per million tests by moving up one level. Not everybody in the population gets tested. Now it's Michigan on the left, 1,400, Rhode Island on the right with 700. It reversed. Rhode Island was higher per population, per capita. Michigan is higher per test. And then if we jump to the top of the pyramid, cases, that's where a person has been tested and they test positive for COVID. Michigan is still higher than Rhode Island. So we've got 3 different denominators here. And the question is, well, which one's right? Maybe none of them. Population, I'd argue, is the furthest from what's best. You've got people that have never been infected. And tests aren't what I want because many of the people that get tested, they're not infected. If you're not infected, you can't die from COVID. Cases, I would argue, is too small. Yeah, these people have been infected and they test positive. That proves they're infected. But are there infected people that don't get tested? Absolutely. I'm saying what we would like is the death rate per infection. The problem is we don't have that data. And now we have to argue of the 3 other denominators, which is better. What's the one that's cited most often? Per million population. I'd argue that's the worst. What's the point of this? The comparison depends on the denominator. This is what makes statistics different than math. Now, let's take on a more controversial case. Do you realize that when we're talking about COVID, people that are vaccinated and have been tested positive, they're vaccinated cases. Vaccinated cases are more likely to die of COVID than unvaccinated. You say, show me the data. Well, here it is. Unvaccinated, about 0.2%. Vaccinated, 0.4%. Vaccinated are at least 2 times as likely to die as unvaccinated. You say, well, how many people was this? 20? 2,000? No. We're talking about 100,000 or more in each group. Well, who did this study? The National Health Service in the United Kingdom. 3 months worth of data. It's big. And you say, I'm not convinced. I'm not convinced that vaccinated cases are more likely to die. If that's the case, the lawyers would be on the doorstep of the vaccine manufacturers suing them for causing death. I don't believe it. And there's nothing in your arithmetic that's going to help you with this. But this is statistics. The context matters. What else could influence death among people that are vaccinated and unvaccinated, but they have tested positive for COVID? Well, they may have other medical conditions. Well, a pretty common medical condition is age. We just happen to have that data. We've got the death rates broken out by age for the same group of people. For the young, under 50, who's more likely to die? The unvaccinated. For the old, 50 and over, who's more likely to die? The unvaccinated cases. Now, stop right here. Who had the lower rate among the young? The vaccinated. They win. Who had the lower rate among the old? Vaccinated. They win. It's like we've got a first and second half for a basketball game. The vaccinated won the first half and they won the second half, but they lost the game. That's impossible with counts, but it's possible with ratios. That's something students have never seen in 12 years of high school mathematics, of school mathematics. They won't see this until they take Calculus 3, differential equations, and they study the difference between a total and a partial derivative. This is huge. This is huge. Unvaccinated are more likely to die, young or old. What explains this reversal? It's called Simpson's paradox. It's the mix. Old people are much more likely to get vaccinated. Young people are much more likely to be unvaccinated. The situation is confounded by age. The simplest way is just break it out, stratify it. You can see the results. Let's take a look at a more complex case. Because you say, I really want to understand how this works mathematically. We're going to talk about family income by race. Here we have mean income for white families and black families. The US 2020, roughly 120 versus 80, a difference of roughly $40,000. That's huge. It's almost, whites are almost 50% greater mean income than blacks. This is a big disparity. Could this be caused by discrimination? Absolutely. Does this prove it's caused by discrimination? Absolutely not. These are statistics. They can be confounded. Well, what could influence family income? And my students will say, well, education, jobs, and finally somebody will say, well, these are families. Number of adults in the family. Is it headed by a married couple or a single parent. We just happen to have the data here for the married. It's a difference of less than 20K between white and black. For those headed by a single parent, it's less than 15K. And you say, wait a minute. If the difference is less than 20K for married and less than 15K for unmarried, how can it be almost 40K for everybody? Well, this isn't a reversal, but it's an increase. Now, how can you take into account family structure? In this case, whether people are married or not. Well, what you need is another statistic. What percentage of each family group are headed by a married couple? Among whites, it's 77%. Among blacks, it's 47%. As I say to my students, it's the mix. It's the mix. You need to take into account the mix. And here's the math for a weighted average. And to finish this off, we're going to standardize on what is true for the entire population. 73% of US families are headed by a married couple. And if we use that 73% on both groups, we get something like 100 versus 120, a difference of only 20K. More than half, around half of the black-white income gap is eliminated. Now, does it stop here? No. Discrimination could be responsible for the difference in the percentage that are married. Statistics takes you deeper. Here's the source on this one. So there's a new course, Statistical Literacy, Math 1300, University of New Mexico, Studying Social Statistics Encountered by Consumers, the story behind the statistics, the influences on social statistics. It's a math course. It satisfies a general education requirement. Students liked the course. In an anonymous survey, half said this course did more to develop their critical thinking than any other course they had taken. A fourth said statistical literacy should be required of all college students for graduation. Conclusion. Students majoring in the humanities need to learn how to evaluate everyday statistics. If they can't do that, they're illiterate. Faculty in the humanities must push their math colleagues to offer a confounder-based statistical literacy course for students in the humanities. Thank you. Here are some references. Best wishes. As we say in dealing with statistics, take care.